Hi, good afternoon. I assume you can hear me. Thank you for the opportunity to speak, and I've enjoyed the last presentations. I've not understood everything, but it's been quite insightful. Today, I'm not going to teach you about high-speed rail. You're obviously learning quite a lot, and you'll become a lot of experts in the next couple of years dealing with the project. The reason for sharing this slide is just to demonstrate the complexity involved and the interfaces involved. And all of these have to be considered as part of the FEED, or the front-end engineering design. I've worked on a number of high-speed rail projects, and I've been delivering BIM and digital solutions for high-speed rail. And I have a lot of experience in planning for high-speed rail development. So my slides today are going to share with you some of my experience of the planning of the digital engineering and the BIM for these complicated, sophisticated high-speed rail projects. So very quickly, you've heard a lot about FEED this morning or this afternoon. It covers a large area of work. Some people estimate it to be about, if it's done correctly, at 2% of the total project cost. So this involves a lot of engineering, a lot of assessment, a lot of detail. And if it's done right, it can lead to significant savings. One of the things that I want to focus on in my presentation, apart from the early contractor involvement, the project planning, the cost management, is specifically digital engineering. And digital engineering, I think there are 4 things that you should be considering as part of FEED. So under digital engineering, the most important thing that you can consider at the beginning of the project is how you're going to collect the information to actually manage the facility and manage the railway in the future. So being able to understand and map out all of the asset information requirements, all of the facility management data, all of the operational data is going to be absolutely crucial. So in the next 12 months, as part of FEED, this should be a priority for the authority to understand how we're going to manage digital engineering and how we're going to collect asset data throughout the life of the project, from design through construction and then handover to operations. And what this looks like in a very simple term is that this process of establishing the asset information model, it begins at the beginning of the design process. So the data is collected throughout the design. The most of the data is collected during the construction phase, and all of that data needs to be gathered in a manner that can be handed over to the operator in the form of an asset information model. So during the design and construction stage, you will hear about people talking about BIM. Sometimes you hear them talking about PIM. You hear them talking about common data environments. These are all different ways of collecting information, but ultimately the operational information has to be collected by the high-speed rail authority. So one of the ways of doing this, and one of the things that needs to be considered as part of this process at FEED, is establishing a classification system for the data. So in order to do that, you need to understand all of the different assets that are in your system. So you've got your rolling stock, you've got your stations, you're going to have your tracks, you're going to have all the communication systems, many assets, thousands and thousands of assets. These must be classified, and they must be categorized so that you can actually find the data and manage the data. So one example I'm going to share with you is how we manage this for an underground metro project. The logic still applies to high-speed rail. So you basically are going to have a number of entities. They could be stations, they could be crossovers, they could be bridges, they could be tunnels, and it's going to be identified in a certain code. And then inside that entity, you're going to have spaces or volumes, and all of that information needs to be categorized and classified so that you can find assets based on their location. Everything on a 1,500-kilometer railway will be based on location. So all the locations need to be defined, they need to be classified, they need to be coded, and then you can start to understand where the assets are that you have to maintain and operate. And then inside those assets, or inside those buildings, you're going to find systems. So you're going to have different types of systems. You're going to have railway systems, you're going to have building systems, you're going to have drainage systems, fire systems. Each system is made up of many components. And then inside those systems, those components are going to be labeled and created as products. It could be a fan, it could be a pump. So as part of the planning for the high-speed rail, it is absolutely essential that this data structure is planned out and that is not left up to design consultants or contractors to figure it out as they go forward. So it is absolutely critical that the owner defines all of these information requirements. And we're quite happy to support you in developing those standards and those requirements. But the owner is responsible for developing their operational requirements and making information mandatory for the consultants and contractors to actually deliver. So that's the first part of the puzzle, is actually establishing the owner's information requirements for their asset management. What you will all be familiar with is BIM, or you'll at least heard the term BIM. For many of you, it may just be a 3D model. For many of us that have done it before, it's the backbone for all of the information that will be gathered. So we look at BIM across a number of different key constraints. So in order to get BIM correct on your projects, again, it is essential that the High Speed Rail Authority defines what they want from the BIM process. So we can make sure that the designers and contractors are meeting your digital engineering requirements, and we can make sure that there are audits completed, that we can actually develop a really good practical BIM roadmap. There are 5 key areas that need to be considered. The 3D modeling is going to be the most important at the beginning, making sure that all of the alignments are modeled, all the bridges are modeled, all the crossovers are modeled, etc., etc. Once the models are being developed, then it will be down to the engineers to do the coordination, just to make sure that everything is actually going to fit together, so that the pipework is fitting inside the structures, the railway systems are going to fit in the viaducts, and so on and so forth. You can then start to use the models for scheduling, and you can also use the models for quantification. So by building good quality models, by establishing the requirements that they'd be used for scheduling, that they'd be used for quantities, you can start to manage the project and manage your costs and manage your planning and manage your program. These are tasks that can be assigned to the consultants, these can be assigned to the EPC contractors, but it is driven by the owner's requirements that the models are used and are built upon all of this. And then ultimately it comes down to information management. How do you collect the information that you're going to use to run your facility in the future? So it's not just about the design and construction phase. It is also fundamentally about the data you're going to collect so you can actually run and manage the facility in the future. So during that kind of FEED process, in order to come up with your BIM plan, you need to start considering who will be involved in the project team at different phases of the project. During the design phase, what skills, what talent, what capability required during construction, during commissioning, during handover. All of the different phases of the projects need to be considered and to a certain extent planned out. The roles and responsibilities need to be considered between the different teams. So between the owner's team, the design team, the construction team, the supply chain, etc. Absolutely critical is setting up the communication and collaboration coordination procedures. And this can be supported with technology. So this can be supported with common data environments. It can be supported with cloud solutions. And the method by which the information is shared is important. And again, the uses for BIM on the project can be defined. So you can have a light touch or you can have a very substantial touch. And there are a number of really, really good examples of how BIM is being used for high-speed rail. HS2 has had some success stories. We had a good HSR project in Malaysia, which had good requirements for BIM. So there are a number of existing documents that clearly specify how BIM can be used. And above all else, the authority can lean on and start to apply international standards. So there are good standards around ISO 19650 for information standards, for asset management, and there are many guidelines available. So the information is available, and it's up to the authority to follow it through. A couple of lessons learned from the projects and what you can expect going forward. This is an elevated train system that we worked on in Malaysia. You can assume that the architects will be able to work in 3D. It is not unusual that the architects will work in 3D anyway. So the architects will have the ability to do the models, but they will not be experienced in coordinating train systems or railway systems. And not many architects have worked on high-speed rail. So the architects will require training and support when it comes to the coordination, particularly with the engineering teams. When you get to the engineering teams, again, it's normal for the engineers to work in 3D. So you can expect a good quality of service from the structural engineers. Less so from the civil engineers. So when you actually get to doing the viaduct layouts, the embankments, the bridges, you're going to need to provide a little bit more support and a bit more training. The way this has been done on projects globally is they've established academies where they've actually trained up the local engineers, the local staff to use these tools. And again, we can help you with mapping out the academy. It is a small investment with a huge return. So by upskilling the industry, you can actually start to get value from the process. The biggest challenge on all of these projects will be the systems, the railway systems, mechanical systems, electrical systems. They involve a lot of complexity and a lot of coordination. This is where most of the effort will be required in actually resolving and sorting out coordination issues. And again, once you start to put all these systems together, you can expect to identify coordination issues, buildability issues, cost issues. So relying on the models as a matter for actually planning and assessing the project is going to be absolutely crucial. And we would urge that a railway team actually get familiar with using these tools to review the designs. So above the modeling situation, one of the key things that needs to be considered is the delivery of drawings. So for example, I mentioned HS2 on projects like HS2, Crossrail, MRT2 in Malaysia. The drawings were mandated to come from the models. In order for you to actually drive this process, it is essential that the owner specifies how the drawings are being produced. So the third pillar in this digital engineering strategy, and this is probably going to be more beneficial than BIM at the beginning of this process, particularly during the FEED, is a geographical information system. And we would urge you to look at the entire alignment and look at it at macro level detail, at kilometer level, and then go all the way up down into micro level, meter by meter. To do this, you need this geographical information system. A GIS system can incorporate huge amounts of information in a very easy to access format. So you can have all of your 2D data in the GIS platform. It is all location-based data, so you can see the alignment, you can see the station locations, you can see the allocation of land acquisition, you can see the existing land boundaries if those things are available. And then you can provide that information across the web. So teams that are working across this project, whether they're in Hanoi, whether they're in Ho Chi Minh, whether they're overseas, they can all have access to the same information at the same time. And they're not relying on sharing CAD files and sharing information. So the GIS information is going to be the backbone of this project, and it needs to be established as soon as possible. In addition to 2D information, as the models are developed, as the alignments are developed, they can all be included into this system. So you can actually include the 3D information for this project. So again, we've done this in projects in Malaysia. We had planned this for the project for the high-speed rail. Someone's making noise in the background. We have also managed to use this, and we've seen examples of this being used on the high-speed rail project in the UK. We've seen it being used on the high-speed rail project in California. Being able to use the 3D models, and then also what I'm going to show you in a minute, reality capture, is a key part of GIS. So the GIS, basically, again, you can include utility information if it's available. You can include TBMs if you've got tunneling machines. You can include information from drones. You can include data around the population density, et cetera, et cetera, et cetera. So GIS is a really, really powerful way of actually managing a project, especially during the FEED stage. And then the final pillar in this is reality capture. So the reality capture is basically a process by which you actually digitize the existing environment. So you would survey the alignment through Ho Chi Minh, you would survey the alignment through, somebody else is clicking on something, hang on. Who will, can you make sure you're muted if somebody's not muted? I hear keyboard clicking. Sorry about that. So reality capture is a key part of delivering these projects. And what I mean by that is you can take the real world and you can digitize the real world. So where you have an alignment, where you have an existing facility, you can digitize that. And then you can use the digital model linked to the real world model to start working on your design and design layouts. There are a number of ways of doing this. I'm not going to go into detail today. We can follow up again if somebody would like more detail. You can use laser scanning for high density point clouds for high accuracy. This is important if you're trying to make sure that you've got headrooms for railway corridors under existing structures. If you don't need the accuracy, you can use drones. Drones can be, is this example, propellers, or they can be fixed wings. Fixed wings will be more useful given the length of the alignment, so you can capture a lot more information. And then as the project's progressing, we'd recommend using 360 cameras to actually monitor the project, so you can actually record the project as going along. All of these technologies, the lasers, the drones, the 360 cameras, these create the reality capture meshes or the reality capture models that you can then use as part of your design, engineering, and coordination process. So again, it's an important part of the puzzle. So in terms of how we can support you in this process going forward, we can help you with advice on which technology to use, and we can help you to develop your strategic documentation. We can help you develop your specifications. We can keep you advised on what the new technology is going to be, whether it's virtual reality, augmented reality, whether it's reality capture. We can also support you with data analytics, and we can help you understand how these are going to transform the construction industry over the next 8, 10, 15 years through the life of the project. So our process is to work through a rigor of identifying which solutions are actually of most valuable to you as the owner, and which solutions you can mandate the design team to use, the construction team to use. And we can help you to assess different platforms, different solutions, and then we can give you advice on how to actually deploy them. And then last but not least, when it comes to actually BIM, we can actually help you to define what the requirements are. So we can help you set out the BIM requirements, your employer information requirements, and we can identify all the BIM best practices. For example, establishing a BIM academy. And we can also then, as the project progresses, we can support you with actually checking of what's going on. So we can provide you with analysis of the information that's being provided by the consultants, the information that's being developed by the contractors. And last but not least, we can actually work with you through the process of appointing the EPC contractors to making sure that they and their supply chain can actually meet the requirements. So there are ways of assessing the capabilities, the capacities, and the experience of the different EPC contractors to make sure that they understand your requirements and can deliver your projects. So that's it in a very quick summary. I believe that digital engineering is an absolute fundamental requirement for high-speed rail. And again, we're very happy to have future conversations about how we can support you in understanding the best way of deploying digital engineering for your projects. So again, thank you very much to Trung and the team at SCL for giving me the opportunity to speak. And I look forward to your questions. Thank you all very much.